Good morning, students. Very good morning to all. Today we have to discuss about hybridization of complex compounds. Okay? For complex compounds having different hybridizations with different coordination numbers. Okay? For suppose coordination number 4 has two types of hybridizations, that is sp3 and dsp2. Okay, sp3 means here geometry tetrahedral. dsp2 means here geometry square planar. Then coordination number 6. Okay, coordination number 6 has two types of hybridization, sp3d2 and d2sp3. Both are containing octahedral geometry. Okay, then coordination number 5 also. Okay, pentacarbonyl iron. So coordination number 5 has two types of hybridization, sp3d and dsp3. In these two, geometry is trigonal bipyramidal. Okay, this is coordination number 4 means hybridizations sp3 dsp2. sp3 means tetrahedral, dsp2 means square planar. Coordination number 5 sp3d and dsp3, geometry trigonal bipyramidal. Coordination number 6 sp3d2 and d2sp3, geometry has octahedral. Okay, here generally two types of d orbitals involving in hybridization. Okay, case 1, if n-1d orbitals involving in hybridization, that is called inner orbital complex and low spin. Examples: dsp2, dsp3, d2sp3. Okay, next case 2. nd orbitals involving hybridization. Okay, in this case, outer orbital complex and high spin. Okay, here sp3d, sp3d2. Okay, so we have two types of d orbitals involved in hybridization. If n-1d orbitals involving means, that is called inner orbital complex and low spin. If nd orbitals involving in hybridization, that is called outer orbital complex and high spin. Our NEET syllabus, inner orbital complex examples: dsp2, dsp3, d2sp3. Outer orbital complex sp3, sp3d and sp3d2. Okay, this is. Now we before we have to discuss about nature of ligand. Okay, what is the nature of ligand? Case 1. If strong ligand, okay, the electrons are, if in presence of strong ligand, the electrons undergoing to pairing. Electrons undergoing to pairing. A knot obeys Hund's rule. Okay, next. Case 2. If weak ligand, in presence of weak ligand, electrons not undergoing to pairing. Here follows Hund's rule. Okay, here follows Hund's rule. Strong ligand means electrons undergoing to pairing. Weak ligand means not undergoing to pairing. It follows Hund's rule. Okay, now we have to discuss some examples. For example, CO NH3 3 flats. Here, amine is the strong ligand. Amine, what type of ligand? Strong ligand. In presence of strong ligand, electrons undergoing to pairing. Okay. Cobalt oxidation state 3d7 4s2. Cobalt 3 plus means 2 electrons eliminate from 4s, 1 electron eliminated from 3d. That means 3d6. Now, here D subshell 1, 2, 3, 4, 5. In presence of strong ligand, electrons undergoing to pairing. That's why 1, 2, 3, 4, 5, 6. Pairing takes place. Now, we have 2 vacant orbitals is there. These 2 vacant orbitals involves in hybridization. Here, cobalt bonded with the how many ligands? 6 amines, 6 ligands. Okay, that means central atom bonded 6 ligands means central atom formation 6 bond. Each bond equal to how many electrons? 2 electrons. 6 into 2, 12 electrons. Understand now? Listen again. Here, cobalt bonded with 6 amine ligands. That means cobalt to 6 ligands formation, 6 coordinate covalent bonds. 1 bond equal to 2 electron, 6 bonds equal to 6 into 2, 12 electrons required here. 12 electrons required. That's right. Here, 2, 4, remaining 8 electrons, 4s, 6, next to 4p. Remaining electrons filled in 4p. 8, 10, 12. 4, 6, 8, 10, 12 electrons. So how many electrons required? 12 electrons. Why? 6 bonds. 6 with 6 ligands, 6 bonds. 1 bond equal to 2 electrons. That's why what is the hybridization? D2 SO FP orbitals. That's why D2 sp3. D2 sp3 means what is geometry? Octahedral. Okay. Now this is strong field and weak sp3 hybridization. That's why this is inner orbital complex. Inner orbital complex means low spin. Then already knows when the unpaired electrons present in D subshell, that leads to paramagnetism. Already you know magnetism. If unpaired electrons present means exist paramagnetism. Pairing electrons means diamagnetism. So where in D subshell? Here in this D subshell, no unpaired That's why this is diamagnetism. Diamagnetism. This is about the CONH363 plus. Next, another example we have to take. Then COCl6 3 minus. Okay, your chlorine acts as a weak ligand. What is the oxidation state of cobalt here? +3. Cobalt +3 means already we discussed 3d6. Okay, 3d6. Then in presence of weak field ligand, electrons does not undergo into pairing. It follows Hund's rule. Okay, that's why here 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, now here how many unpaired electrons is there? 4 unpaired electrons is there, but not undergoing to pairing because it is in presence of weak field ligand. Understand now? Here cobalt bonded with how many chlorine ligands? 6 fluorine ligands. That means cobalt formation with ligands 6 bonds. 6 bonds means 12 electrons. We have 12 electrons required, but here 3D shell no vacant. That's why these 2 electrons filled in 4s, 4p, 4p and 4d. This is important. And 4d. 4d. Okay, here involving nd orbital. 3d means n minus 1d orbital. 4d means nd orbital. So we are involving nd orbitals. So what is hybridization? Yes, 3p orbitals filling. From 4d only 2 orbitals filling. That's why sp3d2. sp3d2 means outer orbital complex, because outer 4d orbital involving now. If 3d orbital involving means inner orbital involving, inner shell involving. Here outer shell involving. Okay, so outer orbital complex and high spin. Outer orbital complex, high spin. Then here sp3d2 also octahedral complex. Octahedral complex. Then here 4 unpaired electrons are present. That's why it should be para. When the unpaired electrons present in n-1d subshell, that is called paramagnetism. That is exists to para. That's why this is paramagnetism. This is about the COCl6. Next. Next, another one. Cadmium Cl6. Okay, here -3. Please remember, cadmium Cl6 -3. Here your doubt is, this is weak field ligand. That's why electrons do not undergo into pairing. Okay, but this is cadmium is the 4d series element. So listen students, in presence of strong field ligands, electrons undergoing to pairing. In presence of weak field ligands, electrons do not undergoing to pairing, follows Hund's rule. Okay, now that applicable only for 3d series elements. That means scandium to zinc, 20 atomic number 21 to atomic number 30. 3d series elements only apply. In case of complex compound formed by 4d series elements and 5d series elements, undergoing to pairing. Again listen. For 3D series elements, scandium to zinc in presence of strong ligand undergoing to pairing. In presence of weak field ligand follows Hunt's rule. Do not undergo pairing. But in case of 4D and 5D series elements, either weak field or strong field, whether weak field or strong field, electrons undergoing to pairing only. Important one. 4D, 5D metals to form complex compounds, whether weak or strong field, weak or strong ligand, electrons undergoing to pairing only. Electrons undergoing to pairing only. Okay? We are not obeys Hunt's rule. So 4D and 5D series elements, whether weak field or strong field ligand, electron undergoing to pairing only. That's why a cadmium bonded with 6 chlorine ligands. Generally chlorine is weak field, but cadmium belongs to 4D series. That's why your electrons undergoing to pairing only. Pairing only. This is 4D and 5D series elements. Next one. For example, CO, NH3, 4, Cl2. In this case, amine is the strong field ligand, chlorine is the weak field ligand. Chlorine is the weak field ligand, amine is the strong field ligand. So what rule we have to follows? When the strong field ligands and weak field ligands together come, we have considered strong field ligands only. That's why when the strong field ligands and weak field ligands associate together in complex compounds, we consider strong field ligands only. So strong field greater than weak field ligand. Strong field ligands only we consider. Strong ligands only we have considered. Okay? That's why your electrons undergoing to pairing. Electrons undergoing to pairing. Electrons undergoing to pairing. So here what is the oxidation state of cobalt plus 2? Here cobalt plus 2 means what is the configuration 3D8. We consider only strong field ligand, then weak field ligand. That's why electrons undergoing to pairing not always Hunt's rule. So 3D8, 1, 2, 3, 4, 5, 4, 6, 8. Okay now here cobalt bonded with how many ligands? 6 ligands. 6 ligands means how many bonds formation? 6 bonds. 6 bonds means how many electrons required? 12 electrons required. But here from 3D how many vacant orbitals is there? Only one vacant orbital. sp3 how many orbitals contribution? 1s 3p orbitals. 4 orbitals contribution, 4s 4p. 4 orbitals means 8 electrons. For example, here 2 means again 2 electrons taken from 4d. So remember one important point. In hybridization, only 3d involving or only 4d involving. 3d and 4d never involving in association. That's why here 3d subshell not enough of vacant orbitals. Yeah, vacant orbitals not enough. Okay, that's why we are taken from 4D subshell. Okay, that's why 4s 4d. That means 12 electrons here. So here sp3d2. sp3d2. Remember although strong field ligand, here not enough of vacant orbitals, it undergoing to outer orbital complex hybridization sp3d2. Here in this case what happening? Here beside one vacant orbital is there, this electron shifted to here. That's why now 3d orbitals having two unpaired electrons. Okay, that's why although strong field ligand, although undergoing to pairing, here not enough of vacant orbitals. That's why taken from 4d orbitals. Here vacant orbital is there, that's why electron shifting. That's why 3d subshell we have two unpaired electrons is there. So although strong field ligand considered, it undergoing to paramagnetism. This is very important. That's why many books given strong field ligand means dia, weak field ligand means para, but 100% not correct amma. Depend on hybridization, depend on electrons excited state, we have to explain diamagnetism and paramagnetism. Okay, we can't tell based on the strong field and weak field. Maximum 85 to 90% correct only, but many compounds not obey because based on the excitation of electrons. So your strong field ligand only consider, but it can show paramagnetism. That's why based on the hybridization only we have to explain diamagnetism and paramagnetism. This is next. Then we have to take coordination number 4, some examples. Nickel Cl4 2 minus. Okay, your chlorine is a weak field ligand. Okay, that's why your electrons follows Hund's rule. Nickel oxidation state here +2. Nickel +2 means what is the configuration? 3d8. 1, 2, 3, 4, 5. So, in presence of weak field ligand, electrons do not undergo pairing, follows Hund's rule. That's why 1, 2, 3, 4, 5, 6, 7, 8. So, in 3D, no vacant orbitals. But here nickel bonded with how many chlorines? 4 chlorines. 4 chlorines means how many bonds formation? 4 bonds. 4 bonds means 8 electrons. This 8 electrons is taken from into filled in 4s and 4p. Okay, that's why this is sp3 hybridization. Okay, then outer orbital complex. sp3 means what is the geometry? Tetrahedral. Next to here unpaired electrons is present. 3d 2 unpaired electrons is present. That's why it shows paramagnetism. This is about NiCl4. Next one. NiCl4. NiCl4 2 minus. Here also cyanide is the strong field ligand. Nickel oxidation state +2 3d8. In presence of strong field ligand, electrons undergoing to pairing. 1, 2, 3, 4, 5. That's why 2, 4, 6, 8. Here nickel bonded with 4 ligands. That means 4 bonds, 8 electrons, 4 orbitals required. Here 1d, and 4s, and from 4p fill it to 4p orbitals. That's why here DsP2 means inner orbital complex. Okay, hybridization square planar. Here no unpaired electrons present. That's why this is diamagnetism. This is the diamagnetism. Next one. Nickel tetracarbonyl. A carbonyl is strong field ligand, and this is neutral ligand. Already knows neutral ligand. A nickel oxidation state is 0, plus 0. That's why nickel plus 0 means 3D8 4s2. Okay now. Now, in presence of strong field ligand, electrons undergoing to carrying. Next 4s2 also is there now. 4s2. Okay, this is the 4p. This is 4s. But here 3d one vacant orbital is there, but 4s is filling. That's why hybridization is difficult. That's why 4s electron transfer to 3d. Here electrons should transfer. 4s electrons transfer to 3d. That's why here 3d filling 4, 6, 8, 10. Okay now. That's why now 4s orbital is empty. 4 ligands, 8 electrons. 2 electrons filled in 4s, 6 electrons filled in 4p. Totally hybridization. What hybridization? sp3 hybridization. Tetrahedral complex. Okay now. This is outer orbital. Remember students, although in presence of strong field ligand, it shows outer orbital complex. But here no unpaired electrons there. Although outer orbital complex, it shows diamagnetism. Okay now, diamagnetism. Generally, what they all are thinking, outer orbital complex means para, inner orbital complex means dia. That is not correct 100%. Many compounds not obey. That's why based on the hybridization, based on the electrons migration only, we have to explain dia and para magnetism. So outer orbital complex and diamagnetism. This is about the hybridization of complex compounds. Okay students, thank you.